This video is if you haven't been here over the past few days, or you just need some further explanation on the two types of factoring we've done so far, which is the A equals 1 method and the GCF method. So let's get started. All right, question number 1. The first thing I notice is that there's 3 terms. A lot of times when I'm looking at a trinomial, it's usually going to be A equals 1. And the reason that I know this one is A equals 1 is if you look at each term of the 3 terms as A, B, C, look at this is A, this is B, and this is C. Well, the coefficient of A is 1, the coefficient of B is 11, and the coefficient of C is 18. So A equals 1. So that's why I'm picking the A equals 1 method for this one. Okay, when you have a trinomial, 3 terms, and the first term has a coefficient of 1. Okay, once you know it's the A equals 1 method, the idea here is we're looking for numbers that multiply to C and add to B. So I'm looking for numbers that multiply to 18 and add to 11. One way to do that is to go to the y equals screen and do an 18 divided by x. And when you go to the table of the y equals screen, you'll be looking at the x and the y1. And you're looking for pairs that are whole numbers. So when you look through the table, you would see a 1 and an 18, a 2 and a 9, a 3 and a 6, and eventually you'd see 6 and 3, which is the same combination. So you'll know you're done looking at the list when the numbers start to repeat. So then from here, these are all numbers that multiply to 18, so they meet this criteria. Now I need them to add to 11. So I'm adding the numbers together side by side. So 1 plus 18 is 19. 2 plus 9 is 11. 3 plus 6 is 9. I want to use the pair that adds to 11, which is positive 2 and positive 9. So in factored form, I just put a plus 2 and a plus 9. If I wanted to check my work for this, I could type this into y1 and this into y2, and I would be able to check my answers by seeing if the tables matched. All right, next one. This is another trinomial, 3 terms. The first term has a coefficient of 1. So trinomials with the first term of 1 is the A equals 1 method. So we're looking for numbers that multiply to negative 40 and add to negative 3. All right, so I'm going to go to the y equals screen and I'm going to do a negative 40 divided by x. And then you're going to see this table of values. You're going to see a 1 and a negative 40, a 2 and a negative 20. Next to 3 will be a decimal. A 4 and a negative 10, a 5 and a negative 8. And then the list would continue. I'll just keep going down here. An 8 and a negative 5, which is different. It's not a repeat because the negative's on a different number. A 10 and a negative 4, a 20 and a negative 2, and then a 40 and a negative 1 would be the entire list of factors of things that multiply to negative 40. I'm looking for the pair that adds side by side to negative 3. So like 1 plus negative 40, well that's negative 39. 2 minus 20, that's negative 18. 4 minus 10, that's negative 6. 5 minus 8, that's negative 3. That's the pair that I want. I could keep checking. This would be positive 3, positive 6, positive 18, positive 39. But I want the list that adds to negative 3. And that's going to be a positive 5, so I'll do a plus 5, and a negative 8, so I'll do a minus 8 in factored form. Now what makes this next one different is it's only 2 terms. So the fact that it's 2 terms means it can't be A equals 1. And if it can't be A equals 1, because A equals 1 is trinomials, well then it can't be both either. So it must be a GCF. There are a few ways to do GCF. You can do it by hand or in your calculator. By hand, I could think of the numbers that multiply up to 6. 1 times 6 2 times 3, and that's it. And I can think of the numbers that multiply to 15. 1 times 15, 3 times 5, and that's it. And I can compare those two lists and see what they have in common. They both have a 3. So that's one way to do it. Another way to do it in the calculator is you can math arrow to the right 9, and you can do a 6 comma 15. The key is here that you can't include the negative. If you're using the calculator for this, you just have to use both positive numbers. So I get that the GCF is 3. Now the other thing I have to look at is the x's. This x squared has 2 x's and this x has 1. So what do they have in common? They both have at least 1 x. I can't do 2 x's because this second term here doesn't have 2 x's, but they both have a single x. So that means that they have a 3x in common. So now that I know what the GCF is, I need to divide it out. So I'm going to divide each of these terms by 3x. And when we do division, I'm going to put exponents of 1 on these. When we do division, we divide the numbers in front. 6 divided by 3 is 2. We keep the base and we subtract the exponents. 2 minus 1 is 1. Minus 15 divided by 3 is 5. We keep the base and we subtract the exponents. 1 minus 1 is 0. And I'm not going to write x to the 0 because that just means there aren't any x's there. So in other words, x minus x to the first over x to the first just cancels out the x's. So when I divide this out, I get 2x minus 5. The most important part of the GCF is the actual GCF, so you can't forget that. The GCF goes in the front of your set of parentheses. This way, if I were to redistribute the 3x, I'd end up back where I started. Let's look at the next one. This is number 4. This is a polynomial. There's 1, 2, 3, 4 terms. The fact that there's 4 terms immediately eliminates a equals 1. In order to be a equals 1, it needs to be a trinomial, 3 terms. So it must be GCF. Now, instead of listing out all of the factors, I'm going to use my calculator. I can only use my calculator in steps, though. So I'm going to use the first 2 coefficients of 4 and 8. So I can only do 2 numbers at a time. So math arrow to the right 9, 4, comma 8. Remember, I can't include the negative. The GCF of 4 and 8 is 4. So then what I'm going to do is take that GCF of 4 and pair it with the third number, which is 10. So I'm taking the GCF from the previous, which was 4, and pairing it with the third number, which is 10. So my new GCF is 2. And now what I'm going to do is take that GCF of 2 and pair it with the last number, which is 24, because I can't include the negative. So math arrow right 9. 2, the GCF between my last terms, and then my last number, 24, not including the negatives. So my GCF altogether is 2, meaning I can divide a 2 out of all of these things. Also, I've got 5x's, 4x's, 3x's, and 2x's. All of them have at least 2 x's. I can't divide out of 5 because they all don't have 5, but they all have at least 2. So I can divide out of 2x squared from each of these terms. So remember what we're doing. We're dividing the numbers in front. 4 divided by 2 is 2. We're keeping the base and we're subtracting the exponents. 8 divided by 2 is 4. We're keeping the base and we're subtracting the exponents. 10 divided by 2 is 5. We're keeping the base and we're subtracting the exponents. 24 divided by 2 is 12. We're keeping the base and we're subtracting the exponents, but an exponent of 0 means that we actually don't have an x on that one. What happens is the x's cancel out. So when I divide out the GCF, I get 2x to the third minus 4x to the second plus 5x. I'm not going to write the 1, but you can. Minus 12. Remember that the most important part of the GCF is the actual GCF itself. It needs to be in the front of your parentheses. So I'll need the 2x squared in the front. You can check your work again for all of these by typing the original in Y1 and the factored form in Y2. All right, this next one is a trinomial, which makes me think it's probably a equals 1, but I just have to check that the first number is 1 before I can call it a equals 1. So for a equals 1, I'm looking for numbers that multiply to the last number and add to the middle number. And the easiest way to do that is to go to the calculator and do negative 30 divided by x. And take a look at that table. So we'll have a 1 and a negative 30. A 2 and a negative 15, a 3 and a negative 10. Next to the 4 will be a decimal, a 5 and a negative 6, a 6 and a negative 5, which is different. Nothing next to 7, nothing next to 8, nothing next to 9. 10 and negative 3, nothing next to 11, nothing next to 12, nothing next to anything until we get to 15, and then 30. This is my whole entire list of whole numbers for negative 30 divided by x. I'm looking for the pair that side by side add to positive 1. So 1 plus negative 30 is negative 29. 2 plus negative 15 is negative 13. 3 plus negative 10 is negative 7. 5 plus negative 6 is negative 1. So that one's close because this is a positive 1. But 6 plus negative 5, that's positive 1. So it does matter which number the negative is with. I need it to be positive 1, so I need the 6 to be positive and the 5 to be negative. Otherwise, it would be a negative 1 in the middle. Number 6, I've got 3 terms. That's making me feel like it's a equals 1. I'm just going to double check by making sure that the first term is 1. So I'm going to my calculator and I'm doing a 36 divided by x. Let's see what we've got. We've got 1. Actually, I want them to multiply to positive. So if I do 1 and 36, that's going to add to a positive number. I need it to add to a negative number. So I'm going to look the other way in the calculator. I'm going to arrow up. So negative 1 and negative 36. Negative 2 and negative 18. Negative 3 and negative 12. Negative 4 and negative 9, negative 5, negative 6, and negative 6. So that would be all of the numbers side by side that add to negative numbers. And I'm looking for the pair that adds to negative 13. This one, negative 1 and negative 36 is negative 37, negative 20, negative 15. Looks like this one's negative 13. So I'm going to do x minus 4, because it's a negative 4, and x minus 9, because it's a negative 9. I think there are 3 more on here. It's a trinomial, so I would originally think it's a equals 1, but a equals 3. And so it can't be a equals 1, at least not yet, which means it must be GCF. So I'm trying to see what these things have in common. I'm going to use my calculator because it's quicker. So I'm going to do the GCF between 3 and 45. And then I'm going to take that GCF, 3 and 45. And I'm going to take that GCF and I'm going to pair it with the last number, which is 150. So I'm going to do a GCF of 3 and 150. Another 3. So it looks like I have a GCF of 3. Now normally I would have a GCF that has a variable, but because this term right here doesn't have a variable, I can't divide out an x because they don't have x in common. They don't all have x's. So I can only divide out 3. When I do that, what you'll see is that I'm left with a trinomial where a is 1. So this was GCF because of the 3, but then it's also a equals 1. So this one is both. So at this point, I factored out a 3, and now I'm looking for numbers that multiply to 50 and add to 15. So I go to my y equals screen and I do my 50 divided by x, 2 and 25, and then eventually I come to the 5 and the 10. and those two numbers add to 15. So I would get x plus 5, x plus 10, because 10 times 5 is 50, and 5 plus 10 is 15. But also I've got the GCF of 3 in the front that I divided out. This one's pretty similar. It's 3 terms, which makes me think it's a equals 1, but a doesn't equal 1, a equals 5. So the first thing I have to do is take out a GCF. And if I do a GCF between all of these things, it would end up being 5. Math hourly rate 9 of 5 comma 45 is 5, and then 5 comma 40 is also 5. When I divide the 5 out, I end up with a trinomial where a is 1. So this is both. So now I'm looking for numbers that multiply to 8 and add to negative 9. Now, because they multiply to a positive number, they have to be the same symbol, but because I have a negative 9, that symbol would be 2 negative numbers. And this is really it for the multiplies to 8. And so you can see it's going to be this one. X minus 1, x minus 8, but don't forget we divided out the 5 in the beginning, and so that goes to the front. So this one was both. And the last one here, I'm going to think that it's a equals 1, but it's not because a equals 2. So if I look for the GCF between these things, I can divide out a 2. But this one has 3 x's, this one has 2 x's, and this one has 1 x. Since they all have at least 1 x in common, I can divide out a 2x. 2 divided by 2 is 1, x, subtract the exponents. Remember, this is like a 1, so I get 3 minus 1 is 2. 2 divided by 2 is negative 1. I'm just not writing the 1. Keep the base, subtract the exponents. 2 minus 1 is 1. 24 divided by 2 is 12, and I'd get x to the 0 because the x's cancel out. So I end up with x squared minus x minus 12, which is a trinomial where a equals 1. So this is both. So now I'm looking for numbers that multiply to negative 12 and add to negative 1. So negative 12 would be 1 and negative 12, 2 and negative 6, 3 and negative 4, 4 and negative 3, 6 and negative 2, 12 and negative 1. The pair that adds to negative 1, because this is like a minus 1 here, would be 3 and negative 4. So x positive 3, x negative 4. Don't forget that we divided out a 2x in the beginning, which is the GCF, so it goes to the front. Hopefully this helps with GCF and a equals 1 methods. It's really, really important that you know how to do these. It is the most important thing that you are going to learn this school year.